scientists were able to finally characterize the solar Rossby waves that has been the subject of debates for 40 years. The team found that these waves are similar to the Rossby waves that control weather condition on Earth. MPS. NASA. Hermes-designed scientists discover giant waves on the Sun that have the capacity to rotate similarly to the planetary waves that control the weather on Earth. The group of giant waves is scientifically identified as the Rossby waves. In theory, Rossby waves should be present in every rotating fluid system. However, its existence on the Sun was heavily debated among experts for 40 years. Now, the team of international scientists, led by Laurent Gizons, co-principal investigator of the Center for Space Science at NYU Abu Dhabi, has unequivocally established that Rossby waves, indeed, are present on the Sun. The study is able to list down the wave's characteristics and its vorticity or movement. Solar Rossby waves. And conducting their study, astrophysicists from NYUAD, the Max Planck Institute for Solar System Research, and Stanford University examined data obtained from 2010 to 2016. The data were collected by the heliospheric and magnetic imager instrument that is on board NASA's Solar Dynamics Observatory. The result of their examination, published in the journal Nature, reveals that solar Rossby waves are gigantic in size like their Earth counterpart. They have wavelengths similar to the span of the solar radius. Their vorticity, or manner of movement, is opposite to that of the general rotation of the solar system. Their movement, however, has a well-defined relationship between its frequency and its wavelength. The solar Rossby waves, although gigantic in size, possess small amplitude that makes it difficult to detect. The waves only live for several months but nonetheless contribute half of the Sun's kinetic energy at large scales. Pali Srinivasan, the principal investigator of the study, says that while the team was able to delineate these characteristics, they have yet to precisely identify the role they play in the Sun. Their presence may help us understand solar convection at the largest spatial scales, which remains poorly understood, Srinivasan explains. Earth Rossby waves naturally occur in the atmospheres and oceans of every planet. They formed as a response to the rotation of the planets. Earth has both oceanic and atmospheric Rossby waves. Unlike their usual ocean waves that break along shores, oceanic Rossby waves are enormous. Their movement is undulating, stretching horizontally far across the planet for hundreds of kilometers in a westward direction. With such massive progression, oceanic Rossby waves can change Earth's climate condition. They contribute to high tides and coastal flooding when they pair up with rising sea levels, king tides, and the effects of El Niño. Atmospheric Rossby waves, on the other hand, formed as a result of changes in Earth's geography. These waves help transfer heat from the tropics toward the poles or transfer cold air vice versa. They also help to locate jet and detect the pathway of surface low-pressure systems. Slow-moving atmospheric Rossby waves bring enduring and persistent weather patterns. See now, things you should never search for on Google. You've been warned. Copyright 2018 Tech Times. All rights reserved. Do not reproduce without permission.